nobody really expected this. And 15 strange galaxies, which only existed when the universe was younger than the Big Bang, have been discovered by the James Webb Space Telescope. So we are at the dawn of an entirely new age. We will experience an unparalleled upheaval of our cosmology and of science as a whole, forced perhaps to rethink our entire view of what creation is and why. What if the Big Bang never occurred? Have we maybe found ourselves not in this world, but a parallel one? And why has our science not made sense? At a press conference on current events, Nobel laureate Dr. John C. Mather, lead project scientist for the Webb telescope, said it succinctly. He said of James Webb's discoveries, "This is really exciting because we're looking far back in time than we ever have before. We've worked on the problem of how the galaxies formed, and I thought we would see that in the images, but we'll see something much of a surprise in the galaxies. We expected them to be bigger, brighter, and hotter. Then, some people said our whole story of an expanding universe was wrong. There's a higher chance what our story to how stars formed is wrong, I think. At least 15 galaxies are so old, so massive and so bright they shouldn't even exist. That, anyway, is what the James Webb Space Telescope found. It could have been 6 black holes, which are so old that their beginnings have to be pre-Big Bang. James Webb's pictures, with their series of objects so strange and old that they confuse scientists. Only a handful are complicated enough to have been baby galaxies 300 or 400 million years after the Big Bang. Some of the star clusters that scientists expected to hold the legendary population 3 stars had been found. But these first stars were supposed to be so huge and so luminous, but only lived very short lives. There are more shocks, and James Webb found another galaxy. The low luminosity was so low because it also did not fit into the picture of star clusters with bright supergiants. It could be 6 of the biggest black holes that existed 500 million years after the Big Bang that we need to wonder. Where did all the matter go to make them so big? But previous cosmological models tell us it takes billions of years for galaxies or black holes to take the forms that James Webb is revealing us at the beginning of time. How far do telescopes see? With range of about 13.5 billion years, James Webb also makes an appearance. While the telescope doesn't come much better than Hubble, Webb sees further into space and sees more detail. GNZ 11, the oldest galaxy discovered by Hubble, existed around 13.4 billion years ago. But instead, James Webb has since found dozens of galaxies in the depths of the cosmos, including those with allegedly extreme redshifts of up to Zettiedinzer-20. Scientists have now confirmed 15 of these galaxies, and must explain them. They are visible to us because they once emitted light. Like real-time machines, telescopes receive light. Our view of the past is as if through a tube, and through light signals billions of years old, we can get a vivid impression of how the universe looked when time began. In addition to light, there is another major indicator in the universe: the cosmic radiation. The cosmic background radiation, or cosmic microwave background radiation, is the remnant from the early days of the universe. It still carries messages from remote events through space as an almost uniform radiation field which permeates the universe. The discovery was really just sort of a fluke of Arno Penzias and Robert Wilson, who, in 1965, when they heard this strange noise in space. So it appears as a weak signal that came in from all directions in the sky to beings that reside in the sky, which is perceived by gigantic radio telescopes. Other big things that they confirmed with their discovery included that the universe is expanding and the Big Bang theory. The background radiation is just a reflection of the state of the universe 380,000 years ago, when the universe very slowly began to release photons and create light. Thus, even with the background radiation, we do not see to the Big Bang. Nevertheless, cosmic background radiation lets us work backwards through the composition, density, and temperature of the early universe. From cosmic structures and details from tiny fluctuations in their uniform distribution, scientists can read thousands of such details. Up to here, this has so far helped to explain common cosmological models, but now we have to challenge these findings too. While radio astronomers at the same time continue to listen into space, looking for clues about what happened back then, researchers are now on the trail of the latest mysteries of light, such as shining galaxies or brightly glowing dust disks from black holes. Unusually old GNZ11. But since the new James Webb era, there have been unusual old galaxies discovered that a lot people didn't know about. In 2016, a team of Pascal Oesch and Garth Illingworth surprised researchers that they had detected a very old galaxy using the Hubble Space Telescope with a redshift of ZICAS 11.09. GNZ11 first hit Hubble's observation mirror more than 13 billion years ago. GNZ11 is the most distant known galaxy. This redshift places it as such. But the discovery of GNZ11, an extremely distant quasar, didn't just fascinate the scientific community due to the gargantuan distance it traveled to reveal. Itself, the quasar is also unlike any other. Despite being only young, GNZ11 is surprisingly bright and quite large. When we look at the galaxy, we are looking back in time, only 400 million years since the Big Bang. And because GNZ11 was young when it was, and surprisingly well developed, it had to mean that it's GNZ11, one of the oldest galaxies from our perspective. They estimate that this galaxy complex took billions of years to form. It has an estimated mass of about 1 billion solar masses with a star formation rate of about 20 solar masses a year, and unexpectedly rapid evolution and activity. Managing to observe and analyze GNZ11 just a few years ago was truly a technological challenge. This galaxy is so faint that the light is also very red-shifted, and even using the Hubble Space Telescope capabilities were pushed to the limit. Of course, this strange find has been pondered by researchers in 2016, when GNZ11 was just one of many and considered exotic. And now we know that thousands of highly organized, massive galaxies no doubt already populated the young universe. Even older, JADES GS Zeton 13. Researchers are truly being fooled by the James Webb Space Telescope. The old scientific community is starting to look old. One discovery followed by another. The universe is showing all those people who thought they knew what those first galaxies and stars looked like something different. On September 29, 2022, JADES GS Z13 was observed to be a powerful Lyman break galaxy identified by the James Webb Space Telescope. The discovery was made as part of the JWST Advanced Deep Extragalactic Survey, JADES mission. JADES GS Z13 is a redshift value of 13, i.e., with that the galaxy existed around 13.4 billion years ago and therefore at no more than the period of 400 million years after the Big Bang. James Webb was the only one capable of capturing the light of this extremely distant galaxy using its technique purpose-built to pick up infrared light. It is a phenomenon in astronomy very similar to the expansion of the universe. It happens due to a shift of light from stars or galaxies to longer, red wavelengths. And this is because, most likely, the expansion of the universe that is acting on the light source, or the fact that the objects are moving in a gravitational field, or from the fact that the light source is moving relative to the observer, the so-called Doppler effect. The effect was first discovered by astronomers of the early 20th century, namely Vesto Slipher and Edwin Hubble. Hubble found that there was a redshift, a distance away from Earth proportional to the distance from the point that a galaxy is observed. Our observation led to the Hubble law, which provides not just age and direction of movement of galaxies, but also the expansion theory of our universe. Incredible, see Airs 21-2. And then another came along when researchers thought things couldn't get any worse. The final bit of confusion was Sears 2T1-2. While this barred spiral galaxy isn't as old as the two bar-headed or inverted edge-on spirals, GNZ11, or JADES GS-Z13, this barred spiral galaxy is almost an exact twin to our own Milky Way at A edutainment redshift Zetan3. Sears 2T1-12 formed into spiral galaxies normally after many billions of years, but it is only 2 billion years old when this light was emitted. It's also now evident that Sears 2T1-12 comes from a time when the universe had already turned 3 or 4 relatively ancient years old, but was still in its diapers. Around 3.9 x 109 solar mass for Sears 2T1-2. This also suggests that the galaxy was basically mature for around 2 billion years. All of a sudden, we have awkward questions about how a galaxy could acquire such mass and structure within a time span so short after the Big Bang. And considering that galaxies take billions of years to evolve, we're really not looking at galaxies that in fact are only some hundreds million years, only a couple of billion years old. They had to be older. That is, these galaxies had to exist before the Big Bang. Why is this? It's probably not a big surprise to you as to why the great age of these supposedly young galaxies can be explained. Let's take a look at the possible solutions. The universe is much older. Since the James Webb Telescope made startling finds, we have to admit there's a lot more to the universe than we once thought. But even a theory exits for this, and Rendragupta of Canada and India came up with one too. Using light that tires as it travels through space, he explains the theory of how the universe is expanding. If this turns out to be true, all of our previous distance measurements are probably wrong. The universe has no beginning. Thus far, evidence exists for the Big Bang, but it is not compelling. However, the only thing pointing to it are the expansion and the cosmic background radiation, which may well be wrong. Turning to quantum mechanics, we'll see several indications that the universe is both infinite in time and in space. There was another beginning. Scientists believe there must be at least a dozen other ways to account for how our cosmos came to be, beyond the notion that the entire universe may have been spawned from the tiny speck of a single point. It appears that the universe is receiving flow from several sources, and that these, if not all, must have had their beginning at the same time. There are so many more highlights to come, and press the subscribe button.